Yeah, good evening, children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Yeah, hi, good evening. I've shared my screen, children. Is it visible? It's a blank
Yes,
screen
Yeah,
ma'am.
as
ma'am.
of now. Yeah, just a minute. All right, so before we, proceed with the next exercise from NCRT, we'll just recall all the formulae we have seen in this chapter, mensuration. Yeah, starting from cube. What's the formula to find the volume of a cube? Volume of a cube,
A
A,
cube.
A cube, cubic units. Good. Curved surface area, CSA, or lateral surface area of a cube is given by the area of 4 walls. Each face is a square with area A square. So 4 faces, 4A square. 4A square square units. The total surface area, or the area of all the 6 faces of a cube. Curved surface area, yeah, curved surface area is area of the 4 faces, the 4 vertical faces, 4A square. Total surface area is the area of all the 6 faces, the 4 vertical faces and the 2 horizontal faces. So 6A square, square units. What about the length of the diagonal of a cube? Length of diagonal given by the formula √3A units. And if you want to find the area of 5 faces, area of 5 faces of a cube, what's the formula?
5A square.
5A square. Very good. 5A square. So volume is A cubed. The curved surface area or the lateral surface area is 4A square square units. Area of 5 faces, 5A square square units. The total surface area or the area of all the 6 faces, 6A square square units. Length of diagonal √3A units. Yeah, write down all of you. Make this list quickly. From cuboid, you please write along with me. Yeah. Volume of a cuboid, formula.
LBH.
LBH. L into B into H, cubic units. Okay. The curved surface area or the lateral surface area. Two into 2H into L plus B, or you can write it in 2 ways. You can say 2H into L plus B square units. I'll just write SU, children, for square units. Or you can also write it as 2 into L plus B into H square units. Total surface area. Total surface area. 2 into LB plus BH plus LH square units. Length of diagonal So today, before the next class, please memorize the formula, children. Length of the diagonal is given by root of L squared plus B squared plus H squared units. And if you want to find the area of 5 faces, say it's a cuboid which is open at the top. If it's a cuboid open at the top, then the area to be painted, supposing it's a box, it's a cuboidal box. Okay, so made of some metal. And this box is open at the top. The cuboidal box is open at the top. And if you have to paint this cuboidal box, which is open at the top, only 5 faces are intact. The 6th face, since it's open, there is no material used on the 6th face. So the area available to be painted is the area of the 5 faces. The 4 vertical faces, called the curved surface area, plus the area of the base. If the cuboid is open at the top, the area available to be painted is the area of the 4 walls, the 4 vertical faces. That is the curved surface area or the lateral surface area. Plus one more face, the base, because the base is covered. It's open at the top. So the formula would be CSA, area of 5 faces is equal to CSA plus the area of the base, area of base. So CSA, we know the formula. You can find it separately and add. If you want to find the area of the 5 faces, you can find the CSA, you can find the area of the base, and add these two to get the area of the 5 faces. So I think this is enough. Area of the base is L into B. Area of the base is L into B because the base is a rectangle. The base is a rectangle and its area is L into B. CSA formulas 2 of L plus B into H plus area of the base is L into B. Square units. Square units. Find these two separately. Find the CSA, find the area of the base and add to find the area of the 5 faces. Right on, children? Please write. Let me know when you're done. Done, children?
Just 2 minutes.
Okay. At the end of today's class, I want all of you to send the pictures of your classwork today. All of you without fail. All of you must share the pictures. You don't have to make a like PDF and all that. Just take the pictures. You can take one picture for 2 pages, like keep the book open, 2 pages, 1 picture will do.
Ma'am, for today's class or totally?
For today's class alone, just today's work. Not the whole book, not the whole book. Today's class work, please take pictures. As soon as you finish the session, please take the pictures and share it with me on WhatsApp. Just to make sure that all of you are writing. Yeah, done?
Not yet, ma'am.
Okay, okay. No hurry, I'm just checking. Yeah, yes.
Done, ma'am.
Yeah. Good. So next.
Done.
Yeah. So cube, cuboid, and then we saw cylinder. Volume.
Ma'am, can you just go to the previous page? Let me just take a screenshot.
Okay, yeah. No, complete it if you have not completed. I'll wait.
Yeah, I'm done. I'm done. Completed, ma'am.
Yeah. Volume of a cylinder, formula. Pi r square h, cubic units. Curved surface area, 2 pi r h, square units. Total surface area, 2 pi r into r plus h, square units. Volume, pi r square h. Curved surface area, 2 pi r h. Total surface area, 2 pi r into r plus h. So these are about the solids we have seen so far. We started with the area and perimeter of plane figures. So how do we find the area of a circle? Formula to find the area of a circle?
2 pi r. No. Pi r square. Pi r square.
Pi r square, square units. Circumference or perimeter.
Circumference 2 pi
Circumference,
r.
2 pi r units. Because perimeter is just length. Area is expressed in square units. Volume in cubic units. Length is simply units. So circumference is nothing but the perimeter, length of the boundary. So 2 pi r units. Okay. Semicircle. Should look like a semicircle. Area of a semicircle, children.
Ma'am, half into pi r square.
Very good. Very good, Yarni. Semicircle. Area is equal to half into pi r square. Because area of a circle is pi r square. Semicircle will be half of that. So half into pi r square. Square units. Units is square units. Perimeter. Perimeter of a semicircle. See, you can see that the perimeter, the semicircle is a closed region. Okay, and perimeter is the length of the boundary. So if you walk along the boundary of a semicircular region, if you walk along the boundary of a semicircular region, you would be walking along this arc. This arc and then along this line segment. Okay, see, you'll be walking along this arc and along this line segment. Perimeter is the length of the boundary of a closed region. Perimeter is the length of the boundary of a closed figure. So supposing you start here, you walk like this, you walk like this. Now, what is this distance covered? Now you started here, you have covered this distance. How do you find the length of this distance?
Pi r plus 2r.
Sorry?
Pi r plus 2r, ma'am.
No. You should not read from the book. You should answer my question. I said if you have walked this distance, what is the distance you have covered? You are reading the formula which we have written earlier. I asked you, what is the length? If I walk this distance, what is the length of this distance is my question. The semicircular park is of course like this. This is the semicircular park. The park is a covered, it's an enclosed region. If I have covered only this distance, what is the distance covered by me?
Ma'am, pi r.
Pi r. Why? Because what is the length of this region? What is the length of this? What is the length of a circle?
2 pi r.
2 pi r. The length of the circle, the length of the boundary of a circle is 2 pi r. So this one is half the distance. This one is half the distance. So 2 pi r by 2. 2 pi r by 2. Which is pi r. Which is pi r. The length of the boundary of a circle. The length of the boundary of a circle is 2 pi r. 2 pi r. If you start here, you walk like this, and you come back to this point, the total distance you cover is equal to 2 pi r units. If you walk half that distance, you walk only half the distance. Semicircle, as in a semicircle. Then the distance covered by you will be 2 pi r by 2, which is pi r. So that is what is the length of this arc, pi r. And the length of this line segment, what is the length of this line segment?
R square?
No. R plus R. What is R plus R?
2R?
2r.
2R. 2R. 2R. So a semicircular region, okay, is made up of an arc, which is actually the semicircle. This arc is a semicircle. A semicircular region is enclosed by the semicircle and the diameter. Actually, when we say semicircle, it is only this one. This is the semicircle. This one is called the semicircular region. This one is called the semicircular region. Normally, so whenever you're answering a question from mensuration, you need to read the question, understand what it is based on the information given. Normally, when we say semicircle, it is only this one. This is the semicircle. If you're talking about this one, it is a semicircular region. This is a semicircular region. And the semicircular region is enclosed by the semicircle and the diameter. Semicircular region is a closed figure. It's enclosed by the semicircle and the diameter. This is the center. This is R. This is R. So 2R. And this one is, the full circle is 2 pi r. The length of the full circle, the length of the complete circle is 2 pi r. Half of it will be 2 pi r by 2, pi r. So this one is pi r. So if you walk this distance, it is pi r. And then this distance, it is r plus r 2r. So the perimeter of a semicircular region is pi r plus 2r. pi r plus 2r. You can take out r common and write it as pi plus 2 or 2 plus 5 pi. But this understanding is important. So this is the semicircular region, where this is the semicircle. A semicircular region is bounded by the semicircle and diameter. The length of the semicircle is pi r. And this is the diameter, which is r plus r. This is r, this is center, this is r, this is r. So 2r. So pi r plus 2r. Pi r plus 2r. You can take out pi. You don't have to do all that, but you can take r common and say pi plus 2 or 2 plus pi units. So that's about the area of a see, I've written semicircle. That's what it's used interchangeably. So you need to understand the meaning depending on the context. So here, when I say semicircle, it's a semicircular region. Because area you can find only for a closed figure. Area you can find only for a closed figure. You cannot find the area of this region. Area you can find only for a closed figure. So when we say semicircle, it is a semicircular region. Now, quadrant. Quadrant is a quarter circle. Quarter circle. So see here, like this. This is the center of the circle. This is a quarter circle. So what's the area? What's the formula to find the area of a quadrant? This one is a quadrant. You can a circle. Now these four quadrants put together make the circle. 1/4 of a circle is a quadrant. Yeah, what's the formula to find the area of a quadrant? Full circle is pi r square.
Pi r square by 4.
Yeah, correct. So a quadrant is 1/4 of the circle. So the area of a quadrant will be 1/4 into pi r square. Pi r square is the area of the circle. And the quadrant occupies 1/4 the area of the circle. So 1/4 into pi r square. This one is a quadrant. This one. This one is a quadrant. So the area of the circle is pi r square. 1/4 of it will be 1/4 into pi r square or pi r square by 4 square units. And what is the quadrant enclosed by? The quadrant is enclosed by an arc. This is the arc. And what are these line segments in the quadrant called? What are these line segments in the quadrant called? Why no response? Radius, no? This is radius, this is also radius. Radius. See it? Circle. When it's divided into 4 equal parts, each part is a quarter circle or a quadrant. So the quadrant is bounded by 2 radii and 1 arc. This is the center of the circle, radius, and an arc. Area is 1/4 of the area of the full circle, 1/4 into pi r square units. Perimeter of a quadrant or perimeter of a quarter circle is equal to, it's bounded by 1 arc. The length of that arc will be 2 pi r by 4. 2 pi r by 4. The length of that arc will be 2 pi r by 4. Simple, because semicircle is 2 pi r by 2. Perimeter of a circle is 2 pi r. Semicircle will be perimeter of a semicircle, only that arc. Perimeter of the semicircle is only the arc. That will be 2 pi r by 2, pi r. This arc in a quadrant, the length of this arc in the quadrant will be 1 by 4 into 2 pi r. 2 pi r is for the circle, so 1/4 of that. So 2 1s are 2 2s are, so it is nothing but pi r by 2. Pi r by 2 units. The arc, length of the arc. Let me write it here. How we get, I've written it here, I'll write it here. 2 1s are 2 2s are, so pi r by 2. Pi r by 2. The length of this arc is pi r by 2. Plus r plus r. Plus r plus r. So pi r by 2 plus 2r units. 2r units. Because this one is r, this one is r, and the length of this portion will be pi r by 2. The two line segments are the radius of the circle. So r plus r. And that arc is 2 pi r by 4, which is pi r by 2. See, children, there's nothing to get confused. Let me say something. See, the length of this one, the length of this one is 2 pi r. The length of this one is 2 pi r. The length of this one, semicircle, is pi r, 2 pi r by 2 pi r. The length of this one, which is a part of a quarter circle, quadrant, the length of this one alone, this arc alone, the length of this arc alone is pi r by 2. Because this is 2 pi r, half of that, this will be pi r, and this is half of that, half of the semicircle. See here, this one is a quadrant, this one is a quadrant, this one is a quadrant. Quadrant meaning the arc in the quadrant. Circle 2 pi r, full length 2 pi r. Semicircle 2 pi r by 2. 2 pi r by 2, which is pi r. So the length of this one is pi r. The length of the arc in a quadrant, this one will be half of this one. So pi r by 2. Now, when you have to find the perimeter of this region, perimeter of this region, it is pi r plus r, 2r, or pi r plus d, diameter. If you have to find the perimeter of this region, the length of this one alone is pi r, this one is pi r, plus d, or plus 2r. Similarly, the length of this one alone is pi r by 2. The perimeter of the quadrant will be pi r by 2 plus r plus r. The perimeter of the quadrant, the length of the arc is pi r by 2. The length of this arc in the quadrant is pi r by 2. The perimeter of the quadrant will be pi r by 2 plus r or plus 2r. When it comes to area of a circle, pi r square. Area of a semicircle, pi r square by 2, or half of pi r square. Area of a quadrant, 1 by 4 into pi r square. Pi r square is for the full circle. So 1/4 of pi r square. Is it easy to understand, children?
Yeah, ma'am.
Okay. Yeah, please write down this. Just take a picture of this one, children. Let's just finish off with the formula. Take a screenshot, all of you.
Taken, ma'am.
Okay, all of you.
Yes, ma'am.
All right. Okay. How do you find the area of this right triangle? This one is called the hypotenuse. This one is a hypotenuse. This is one leg. This is the other leg. Okay. So area of a right triangle. Area of 1 second. Area of right triangle is equal to area of right triangle is equal to half into base into height. So half into base is the leg and height is also the leg. So it is half product of legs. Half into product of legs. When we say legs, they are the two sides, not including the hypotenuse. The hypotenuse is the side opposite of the right angle. The side opposite of the right angle is the hypotenuse, the longest side. Leave that. Leave that one. The remaining two sides are called the legs of the right triangle. So half into product of legs. Of course, square units. Square units. Area of a right triangle. Otherwise, area of a triangle in general, will be half base into height. Half into base into height. Square units. Area of an equilateral triangle. Area of an equilateral triangle. Yeah, what's the formula? Equilateral triangle. √3/4 into side square. Or a square. √3/4 into side square, square units.
Mom, should I put the subheading as triangle?
Yeah, you can give the heading as triangle. Yeah. Is that what you asked me, Aishwarya?
Yes, ma'am.
Yeah. Yeah. Then the length of the altitude. Length of the altitude in an equilateral triangle. Length of the altitude in an equilateral triangle is given by √3/2 into side units. Length of the altitude is given by √3/2 into side units. So right triangle area, half product of legs, half into one leg into the other leg. Half into product of legs, square unit. Square units. In general, area of a triangle, half base into height, square units. Equilateral triangle, area √3/4 into side square, square units. Altitude of an equilateral triangle, √3/2 into side units. Take a picture, children. Done?
Taken, ma'am.
Yeah. Class, use the emoji. Raise your hand. Gayatri, Aishwarya, Shreya, Shivam, Surya, Harsha. Finish your exams, Harsha?
Yes, ma'am.
Okay. Yani, Saujanya, Anintika, Gayatri. Anintika, your school has reopened after the exams, or you're on your vacations now?
Ma'am, actually, they didn't even give 1 day break. The next day we had school.
Okay.
So we'll be getting our break from 20th.
Okay. For
That's on,
Vijayadashmi.
yeah, from Friday.
Okay. Okay. Yeah, children. Yeah. When I started the meeting, I did not see Harsha. 1 second. I didn't see. Yeah, Harsha and Anintika. Yeah, from where did you join, both of you? Harsha and Anintika?
Ma'am, I joined about 7:30.
No,
Because
from
my
which part?
network
We started from here. So where were we when you joined the class?
cylinder.
From the TSA one only,
Yes, ma'am. Yes.
from the previous slide.
The previous slide is this one. This is the first slide. This is
Yeah,
the
yeah.
next one.
From,
Okay, this
yeah, from this one, yeah.
this slide. Yeah, where were we when you joined, Anintika?
You were asking them to note down and send the picture after class, something.
Okay. Okay, fine. And Harsha, we were here, is it? When you
Yes,
joined?
ma'am. Yes,
Okay.
ma'am.
All right. Yeah, children. Yeah. Taken? Took a picture? No response. Okay, I'm going to the next slide. Now, trapezium. What's the formula to find the area of a trapezium? Half into sum of the parallel sides into the distance between the parallel sides. Half into sum of parallel sides into distance between them. Distance between them or distance between the parallel sides? Distance between them, square units. So symbolically, it is written like this. So this is in words, half into sum of the parallel sides into distance between them in words. So symbolically, it is half into A plus B. The parallel sides are called A and B. Half into A plus B into H. Half into A plus B into H square units. So the trapezium, if it looks like this, not exactly like this. I'll just tell you what I mean. So these are the parallel sides. Then this one is the distance between them. So A, B, H. If it's a right trapezium like this, if it's a right trapezium like this, then A, B, and this side itself is taken as H.
Okay, ma'am.
No, actually somebody said something. I didn't understand, so I didn't respond. I'm sorry. What was that? Okay. So if the trapezium, if Okay, in the second figure, you can see that one side of the trapezium is perpendicular to the parallel sides. In this figure, you can see that this side, one side of the trapezium, a trapezium is a quadrilateral. A trapezium is a quadrilateral. It has 4 sides. And why is it called a trapezium? Because one pair of opposite sides are parallel. In a quadrilateral, when one pair of opposite sides are parallel, it's a trapezium. And the formula to find the area of a trapezium is half into sum of the parallel sides into distance between the parallel sides. So parallel sides, we understand. Distance between them. Now in this figure, in the second figure, you can see that one of the sides of the trapezium is perpendicular to the parallel sides. See here, this is one side. This is one side of the trapezium and it is perpendicular to the parallel sides. Then that side itself can be taken as the height of the trapezium. That side itself can be taken as the height of the trapezium. While you see here in this first figure, this side and this side, they are not perpendicular to the parallel sides. They are not perpendicular to the parallel sides. In that case, this one is the perpendicular distance between the parallel sides. So half into A plus B into H. Area of parallelogram. Base into height square units. Base into height square units. Area of rhombus. Base into height square units. Also half into product of diagonals. Half into D1 into D2 square units. They're two different formulae. Base into height is 1. If base and height is given, base into height. If the diagonals are given, then it is half into D1 into D2. Half into product of diagonals. Half into length of one diagonal into the length of the other diagonal. Okay, take a picture, children. Done?
Ma'am.
Yeah.
Done, ma'am.
Yeah. Yeah. Area of a quadrilateral in general. Is equal to, see here. This is a diagonal and you will be given the lengths of the altitudes on that diagonal from the opposite vertices. Quadrilateral, I've connected one diagonal. From this vertex, you can see a perpendicular dropped on this diagonal. And from this vertex, perpendicular on the same diagonal. So if information like this is given. That is the length of this diagonal D, the length of this perpendicular H1, the length of this perpendicular H2. What you see here is a quadrilateral. One of its diagonals is connected. And on this diagonal, we have the perpendiculars from the opposite vertices. See here, this is the diagonal. This is, for this diagonal, this is the opposite vertex. For this diagonal, this is an opposite vertex. From there, there's an altitude, H1. For the same diagonal, this also is an opposite vertex. This one is also an opposite vertex. From there, we have an altitude on the same, on it, meaning on the same diagonal. If such information is given, the length of one diagonal and the lengths of the altitudes or the perpendiculars falling on the same diagonal. So if information of this sort is given, then the formula to find the area of the quadrilateral is half into D into H1 plus H2. You can even take away the multiplication signs and you can just write half D into H1 plus H2 like this, square units. You can show the multiplication signs or just remove them. So half D into H1 plus H2 square units. Area of a quadrilateral in general, any four-sided figure. Now, how do we use Pythagoras theorem? How do we use Pythagoras theorem? Now, in this triangle, right angle. Yeah. What is the result by Pythagoras theorem, children?
To find the unknown side, ma'am.
No. Right. I want you to tell me the result by Pythagoras theorem for this right triangle using the sides. Using the sides PQ, QR, and PR.
PR square is equal to PQ square plus QR square.
Very good. Very good, Gayatri. Yes. So the square on the hypotenuse, is equal to the sum of the squares of the other two sides. That's a statement. That's how the statement of Pythagoras theorem goes. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So the square on the hypotenuse is PR. The square on the hypotenuse is equal to the sum of the squares of the other two sides. Okay. Take a picture, children.
Done, ma'am.
Yeah. Now I'll leave you with this question. Find the area Sorry. Yeah. Yeah. So now I want you all to complete writing all the formula in your notebook. Some you had written, the others I asked you to take screenshots. So please complete everything from the beginning and answer these two questions. Those of you who joined late also, if you want me to show any slide, I'll show you now.
Mom, can you show the first slide?
Yeah. First one, this one. All right.
Yes, ma'am, thank you.
Yeah. Anintika and Harsha, you want anything in particular? Since both of you were a little late in joining the class.
From the first slide, please.
Got it then? Okay. All right. Please complete writing all this in your book and then answer these two questions. I'll just get back in 10 minutes, children. I'll come back in 10 minutes. Please complete. Yeah, what's the area of the rhombus ABCD? No, I don't want silence. I want noise. Yeah, children. Area of rhombus ABCD. What's the answer?
Half into D1 into D2.
Okay. What are the lengths of D1 and D2?
Ma'am, 15 centimeter and 8.
15 and 18, huh?
From 9 centimeter. Like
No, 1 second. Name the diagonals in the rhombus ABCD. Name the diagonals.
Ma'am,
ma'am, BD
BD
and AC.
and A.
BD and AC. Okay, so BD and AC are the diagonals. We know the length of the diagonal BD, 18. AC is not known.
Yes,
You
ma'am.
cannot take AB as AC. AB is 15. AC is not given. See, we have two different formulae to find the area for rhombus. One is you should know the base and the corresponding altitude. So here, base is known. Base is any of the sides of the rhombus can be taken as the base. Any side of the rhombus. In a rhombus, all the sides are equal. Okay, so the side of the rhombus is taken as the base. And the height is the height on that particular base. The altitude dropped on that particular base. Base into height. So, well, that we cannot use here. So then we are left with only the other one, half D1, D2. So length of one diagonal is 18. Other one we don't know, but we can find using Pythagoras theorem. So looks like nobody has done that. So we'll do it together.
Ma'am, can I tell you?
Yeah. What's the answer?
Ma'am, at the end, the area I got is 216 centimeters square.
Okay, but what's the procedure?
So I used Pythagoras theorem to find the other diagonal. Then I used the formula half into D1 to D2.
Correct. That's what we should do. Right. You're right. Yes. Correct. So we know that the diagonals of a rhombus are perpendicular to each other. Diagonals of a rhombus are perpendicular to each other. They also bisect each other. Diagonals of a rhombus bisect each other at right angles. All right. BD is 18. So BO is 9. DO is 9. BD is equal to 18. So BO is 9 centimeters. OD is 9 centimeters. AB is given to be 15 centimeters. So in the right triangle, AOB, in the right triangle, AOB, this is 9, this is 15. So in right triangle, AOB, by Pythagoras theorem, AO square plus OB square is equal to the square on the hypotenuse, AB square. See, the hypotenuse square should be, on one side separately. It can be in the LHS or RHS. But it should stand alone on one side. AB is the hypotenuse. So AB square should stand alone on one side. And on the other side, you should have the sum of the squares of those two sides. So AO square plus OB square is equal to AB square. AO square we don't know. That's what we want to find. OB is 9 square is equal to 15 square. So AO square is equal to 15 square is 225 and 9 square is 81. So AO square plus 81 is equal to 225. AO square is equal to 225 minus 81. AO square is equal to 160, 144, sorry, 144. AO is equal to the square root of 144. AO is equal to 12 centimeters. So now class, tell me, AO is 12. What is the length of AC?
12 into 2.
24 centimeters.
24.
Perfect, very good. So therefore, AC is equal to 2 into 12, 2 into AO, 2 into 12,
24 centimeters.
24 centimeters. So like this, we find the length of the other diagonal using Pythagoras theorem. So remember, when you know the length of one diagonal and when the side of the rhombus is given, okay, when the length of one diagonal of the rhombus is given to you, and also the length of the side is given. Using this and Pythagoras theorem, you can find the length of the other diagonal. So you will find AO, which is half the length of the other diagonal, double it to find the length of the other diagonal AC. Now, area of the rhombus is equal to half D1, D2. I'll just do it here, children. Just do it here. Now, area of rhombus, you can write it like this in short. AR is for area, AR. RH is rhombus. So area of rhombus, ABCD, is equal to half into D1 into D2 square units. So half into D1 is AC and D2 is BD. So half into AC is 24. BD is given to be 18. So 2 9s are 18. And for the 36, 3 centimeters square. So when the length of the side of the rhombus and the length of one of its diagonals is given to you, you can use Pythagoras theorem to find the length of the other diagonal.
Ma'am, what's this you've written here in this end, ma'am? AR something.
I did say what that is. AR is area. Open bracket, RH is rhombus. Area of rhombus ABCD. You can also write it like this in short. Area, AR is
Okay,
area,
ma'am, okay.
RH is rhombus ABCD. Area of rhombus ABCD. Or you can write it completely in words.
Copy it down, ma'am.
Yeah, good. What about the next one, children?
Mom, on the first question, I did it on my own, so some of the steps are different, but I got the same answer.
No, the idea is the same, right?
Yes, ma'am. The idea is same.
Yeah, okay, that's fine. Yes. Yeah, what's the answer for the second one? Area of rhombus PQRS. Found the answer? Or still to work on that?
Ma'am, I think I have the answer. I got 84 centimeter square.
84. Can you read out your steps, Aishwarya?
Yes, ma'am. I just wrote area of rhombus is equal to breadth into height.
Base, base into
Sorry,
height.
base into height square.
Okay, but the base is not given, no?
Two, and then I.
Okay, so you just took 11.2 as the base and 7.5 as the height, is it? No, you should take SR as the base because the altitude falls on the side SR. You must take SR as the base because the altitude, you can see this altitude. Okay, let me name it. Let me just call this M. Because the altitude PM falls on the side SR. The altitude PM falls on the side SR.
So I should use Pythagoras theorem to find the bottom part.
No, actually, one second. I'm just trying to say how the formula works, base into height. So the height or the altitude PM falls on the base SR. So you will have to take SR as the base and PM as the height. We have to take SR as the base and PM as the height. So this one, SR is the base and PM as the height. But SR is not given to you. So I want you to answer that question. SR is not given. Yes, are we all there?
Yes, ma'am.
Yeah, base into height. The altitude PM falls on the base or side SR. So base into height here is SR into PM, base into height, SR into PM. SR is not known, is not given. PM is there, 7.5. So how do we find the area?
Using Pythagoras theorem.
Oh. Using Pythagoras theorem, you can get only this portion, no? How will you find SR? How will you find SR? So Aishwarya, you got the right answer, but not able to answer my question. Otherwise, your answer is right.
No, I'm in a hurry. I thought 11.2 was the base, so I multiplied those both, and I did get 84 actually.
No, but 11, the altitude does not fall on the side PS, right?
Yes, yes, ma'am, I get it now.
That's what I'm saying. So you're right. Your working is right. But how do you justify taking 11.2 as the base? You have taken 11.2, that is PS as the base and PM as the height. But PM, the altitude PM lands on the side SR. But you have taken PS as the base, so you need to justify that part. If you justify that, you're right. That's because in a rhombus, all the sides are equal, children. In a rhombus, all sides are equal. If PS is 11.2, PQ is 11.2, QR is 11.2, SR is also 11.2. In a rhombus, all the sides are equal. So SR is also 11.2. So in the second one, area of rhombus PQRS is equal to base into height, base is SR, and the corresponding altitude is PM. SR is 11.2 because PS is 11.2. All the sides are equal into PM, which is 7.5, and the product is 84 centimeters square. All right, children, please register that. In a rhombus, all sides are equal. So this is how we use the formula half D1, D2 and base into height when we have to find the area of a rhombus. So in these two questions, you see the two different situations. So depending on the kind of information provided to you, you will have to decide the formula you'll have to use. So in the first one, meaning to find the area of the rhombus ABCD. To find the area of the rhombus ABCD, we use the formula half D1, D2. Half, not base into height. We use the formula half D1, D2. But there also, we were given the length of BD. AC was not given. So here we use the property that in a rhombus, the diagonals bisect at right angles. So this is 90 degrees and also they bisect each other, which means O is the midpoint of AC. O is also the midpoint of BD. So using these properties of a rhombus, these properties meaning, how did we get a right angle here? Because the diagonals are perpendicular to each other. So 90 degrees here. And then diagonals bisect each other, which means O is the midpoint of BD. That's how we write 9 here and 9 here. And because it's a right triangle, we can use Pythagoras theorem. AB is 15. So we can use Pythagoras theorem to find AO. Using Pythagoras theorem, we find AO, double to get AC. And then half D1, D2. Half into AC into BD will give you the area of the rhombus. While in the second one, we use the formula base into height. But the side on which the altitude lands is not given. But we know that all the sides are equal. So SR is also 11.2. Understand, children? Any questions here?
No doubts, ma'am.
Okay. Now, in the time I gave you, have you all completed your classwork so far with all the formulae and the answers to
ma'am.
these two questions?
Yes, ma'am.
Yeah.
Yes, ma'am.
Okay, see this answer if anybody has to complete. I don't remember if I gave time for this. We all finished this one, right? Yeah, I think I gave you time
I
to write
finished it,
this.
ma'am.
Okay. And this is the second answer. The answer to the second one is here, this one.
Do we have to send the pictures now or at the end of the class?
At the end of the class. You haven't finished your dinner, children? Have your dinner and then send
Done,
the
ma'am.
pictures. Yeah. Okay. Now we'll continue with exercise 11.3. I'm just going to do one or two sums and then we'll just recall algebraic identities and factorization. I'm going to put you with, I think, about 6 questions from 3 from algebraic identities and 3 from factorization. We'll see how much you can recall from memory. Yeah. So here, children, an aquarium is in the form of a cuboid whose external measures are 80 by 30 by 40. 80 is the length, 30 is the breadth, 40 is the height. The base and the side faces and the back face are to be covered with colored paper. The base, the bottom, side faces. How many side faces are there? How many side faces are there?
4.
2.
Yeah. Left side, right side. Only 2 side faces. The faces are called top face, bottom face, left face, right face, front face, back face. Front face, back face. Left face, right face. Top face, bottom face. Top and bottom, left and right, front and back. Front and back. So the base, so that is one face. Base is one face. Side faces, 2 faces. And the back is one face. So totally 4 faces are to be covered with colored paper. So which are the faces not covered with colored paper? Name the faces. Name the faces not covered with colored paper.
The top, ma'am.
Yeah,
The
the
top
top
and the
face.
front.
Correct. The top face and the front face. Because you have to see the lovely fish swimming in the water, right? So you cannot cover the front face and the top face. The front face and the top face. The side faces are covered with colored paper. The side faces. The back face also. And the bottom. So 4 faces are covered. 2 faces are not covered. That is the front face and the top face. They are not covered. Now the question is find the area of paper needed. I'll just get a book, children. I just need a cuboid. I'll just get a book and get back. Oh, I think my background is blurred, so I'm not able to show it clearly. 1 second. I'll just change my background. Yeah. So now this is the front face, children. Front face. Right behind is the back face. Depends left, right, according the, it's different from your perspective. So left face, right face, top face and bottom face. Now tell me the dimensions of the front face using L, B and H. The dimensions of the front face using L, B, H. What is this for the cuboid? What is this for the cuboid?
Edge.
H. This one. This is the cuboid. This one is what for the cuboid? L, B or H?
L, length.
L, L. What is this for the cuboid? This one.
Height.
This one, this height. So what's the area of the front face? L into H. See, the front face is a rectangle. The front face is a rectangle. The area of the front face, this is the front face, it's a rectangle. But what is it? Is it L into B? Or is it B into H? Or is it L into H? What is the area of this front face, which is a rectangle? It has to
L
be
into
one of these three. Yeah, it has to be one of these three. The area of this face can be L into B or B into H or L into H. So see the dimension there. This is L and this is H. So the area of the front face is L into H. And the front and the back faces are congruent. They're identical. The front face and the back face are identical. So the area of the back face also will be L into H. Now the side faces, left and right faces. What are the dimensions we have on the side? What is this for the cuboid? What is this one for the cuboid? You should say L, B or H, one of these three. Is this L, B or H? This one.
Sorry, ma'am, come again.
What is this one for the cuboid? This edge.
Breadth.
This edge is what? The length or a breadth or height?
Breadth.
Breadth. Now, what are the dimensions on this face of the rectangle? This is breadth. And what about this one? This one, this one, this one.
Height.
See, for this face, I'm turning. Okay, so I'm turning the cuboid. Now, the area of this face will be this one, which is the breadth, into this, which is the height. Area of this face will be this one, which is the breadth, and this, which is the height. So breadth into height will be the area of the left and the right faces. Breadth into height. The front face will be length into height. The front and the back face will be length into height. The left and the right faces. See here, this face, breadth. This is the breadth. And this is the height. This one is the height. So breadth into height is the area of the side faces. Now the top and the bottom face, the top, let me show you the top like this. This is the top. This is the top. The top face. So this is L, length for the cuboid, and this is the breadth. So the top and the bottom face area will be L into B, length into breadth, length into breadth. This is the length and this is the breadth. Top and bottom faces area L into B. Front and back faces area L into H. Left and right faces area B into H. B into H. So we need to find the area of the paper needed. So for the base, area is L into B. For the side faces, The area, the base bottom is L into B area. The side faces, the area is B into H. For one face, it is B into H. For two faces, it will be 2 into B into H. Side face, area is B into H. Base, breadth into height, not base, breadth into height. Two side faces, so 2 into B into H. Back face, front and back, same area. So back face area is length into height. So you need to just put the values here. So this is the length, this is the breadth, this is the height. So find L into B, that will be the area of the base. Find 2 into B into H. That will be the B is this one and H is this one. So 2 into B into H will give you the areas of the side faces, area of the side faces, and L into H will be the area of the back face. Add all this to get the total area of paper needed. Take a picture, children.
Taken, ma'am.
Yeah. All of you? Yeah, now answer this question. If you have the NCERT maths textbook, you can just give the reference number, the question reference number. Otherwise, you have to write the question. You have taken a screenshot, so you can do it. Write the question and work the answer if you're using a different textbook at school. Yeah. So now I'm going to give you the questions from algebraic expressions and factorization. Please complete this and then try the questions which I'm just about to write. Please complete this one. All of you have taken a screenshot. Please complete this. Completed that aquarium answer, children?
Almost done, ma'am.
Okay. Yeah. So here we factorize by grouping. We group the first two terms. I'll just help you get started and then you can, help me continue with the answer. You need to factorize by grouping. Group the first two terms, group the last two terms. Now, what is the HCF between the first two terms? The HCF of the first two terms, the highest common factor. What is common between the first two terms? A cube x and x to the power 4. Yeah, the least power is common. The least power is common. So x and x to the power 4, x is the least power. So that's common. So what would you get in the bracket? X into what is the first term?
A cube.
A cube.
A cube. X into a cube is a cube x minus x into what will give you the second term?
X to the power 3.
X to the power 3.
Yeah. Now I've told you that whatever is the sign here, put the same sign. That is after the second term. After the second term, whatever sign you see, plus or minus, whatever is the sign you see, put the same sign, plus. Now, what is common? What is the HCF of the third term and the fourth term? The least power is common. A square A. The least power is the HCF.
A.
A. And between x square and x cube, least power is 2. So, the common factor is x square. A square and A least power 1. So A is common. X square and x cube power 2, power 3. The smallest power is 2. So x square is common. Open bracket. Now ax square into what will give you the third term a square x square. Ax square into what will give you a square x square.
A to the power 2.
A to the power 2.
Sorry. It's A, ma'am.
A. Okay. Then ax square into what?
A minus X.
Minus
X right now.
x. Okay. Let me just check the question because you don't have the identity a cube minus b cube. Just see the question again. One second, I don't know where I picked the question from. Okay. Yeah. No, the question is right. I made an incorrect start. The golden rule we forgot. Whenever there's something common, take out the common factor. Yeah, I'm sorry, children, we'll just go back on the answer. So I've always mentioned this golden rule. Whenever there's something common, when all the terms have something in common, all the terms have something in common, take out the common factor. So now all these four terms, a cubed x, x to the power 4, a squared x squared, and ax cubed have x in common. All of them do not have a, but all of them have x in common. All of them have x in common. So take out x as a common factor. Now what do you get inside the bracket? X into what? X into what will give you the first term, a cubed x? A cubed, right? Minus x into what will give you the second term, x to the power 4. Quickly. Yeah, please. X into what will give us the second term, x to the power 4?
From x cube.
X cubed. Now x into what will give you the third term, a squared x squared. A squared x minus x into what will give us the fourth term, ax cubed. Ax squared.
Ax square.
Ax squared. Yeah. Now group. Now, when we try to group the first two terms and the last two terms definitely have something in common, but the first two terms do not have anything in common. The first two terms are a cubed and x cubed. Ax, they are completely different variables and they don't have anything in common. So you have to rearrange. So whenever it is grouping, we normally group the first two terms and the last two terms. But if there's nothing common, then you have to rearrange. You have to rearrange. So let's try writing a square x in the second place and x cube like this, and we'll try. If this doesn't work, we have to try another way. So I'll tell you how you can make out that it doesn't work. So the first step, children, all the four terms have x in common. If you don't take out the common factor, sometimes you cannot group like what, we cannot factorize like what happened now. All the four terms have x in common, so take out the common factor. That is the first step. And then since there are four terms in the bracket, you can group the first two terms and the last two terms. But when you group them like that, they should have something in common. A cubed and x cubed, the first two terms have nothing in common. So we have to rearrange. So write a cubed as it is and write the third term in the second place and the second term in the third place. And we'll see if this works. Okay. So we have x. Now what's common? Between the first two terms, a is common. A into a square is a cubed plus a into a is a square and x. Now what's common between the I told you, put the sign as it is. After the second term, whatever sign is there, just bring it down as it is. And now between the third and the fourth term, x cubed and x cubed and ax square. What's common?
X is common, ma'am.
X is common. X is common. So now when you x into what is x cubed?
X square.
X square. Now what do you observe? Now what do you have in the what are the terms you have in this bracket? A square and ax. But here you're getting x square, which is completely different from what you have in this bracket. When you're grouping, you must get the same expressions in this bracket and this bracket. You must have the same expressions. When you factorize by grouping, you must get the same expressions in this bracket and in this bracket. The expression, the terms here are a square and ax, but here you're getting x square, which is different from what you have here. So that means this rearrangement is not working. This is how you identify, because you don't know which term to bring where. When you have to rearrange, you don't know which term to bring, meaning how to rearrange. So you have to just try. And when you try, see here, this is how you make out that it doesn't work. The expressions in these two brackets must be the same. So now let's try something else then. So exchanging the second and the third terms do not work. So go back. You can just strike it out. Strike it out. I'm erasing it here. Yeah. So now try to group a cubed and the last term. Last term, children, minus ax square. And then these two terms. All right. So we have written the first term as it is, and the fourth term minus ax square, the fourth term. And then this second term minus x cubed, and the third term plus a square. So this is the first term, this is the fourth term. We're just writing the fourth term in the second place. That's all it is. First term and then the fourth term and then the remaining terms. Now see if this works. So what's common again between the first two terms? A is common. A into a square is a cubed minus a into x square. A into x square is ax square. This minus sign as it is. This minus sign as it is. Between the third and the fourth term, x is common because we have x cubed and x. So x is common. The least power is common. So x is common. Now x into x square. X into x square is x cubed. Now see, it's minus x into x square minus x cubed. Now this minus x into what will give you the fourth term, a square x.
A square.
Yeah. See you. Now this minus x, which is common, into what will give us the fourth term, a square x. So minus into minus is plus, and then a square. So minus a square. Minus a square. Minus a square, because minus into minus is plus. The fourth term is plus a square x. So minus into minus plus. X into a square is a square x. So now you see that the terms inside the bracket, they match. But the order is different. In the first bracket, we have a square minus x square. While in the second one, we have x square minus a square. So this also, we have come across such a situation earlier. So what you have to do is, change the order. Write x square minus a square as a square minus x square, and change the sign outside the bracket. I've told you this. Write x square minus a square as a square minus x square, and change the sign outside the bracket. So minus x will become plus x. Minus x becomes plus x. When you write x square minus a square as a square minus x square, change the sign outside the bracket. So this minus x will become plus x. If it was plus x, it will become minus x. Now, x into, so a square minus x square, a square minus x square. Write it once. And then a plus x. Gather these two terms in another bracket, a plus x. Or you can even write a plus x first and then a square minus x square. Now it doesn't end here, because a square minus x square is of the form difference of two squares. A square minus b square is a plus b into a minus b. Just continue here. I'll just continue here. So that is equal to x into a square minus b square is a plus b into a minus b. So a square minus x square will be a plus x into a minus x into a plus x. So the answer is x into a plus x into a plus x into a minus x. You can rearrange if you want. So there are many takeaways from this answer. Okay, so from this we have many takeaways. The first thing is whenever you have to factorize an expression, look at all the four. Here in this case, we have 4 terms. Carefully look at the 4 terms. If all the 4 terms have something in common, bring it out. That's the most important thing. So here all the 4 terms have x in common, so x out. That's the first step. So after taking x outside, we have these 4 terms in the bracket. Now there are 4 terms, so we tried to group the first 2 and the last 2 terms. But then there's nothing common between a cubed and x cubed. So we had to rearrange. And then we tried one rearrangement. We wrote the third term in the second place and the second term in the third place. But that didn't work because the terms in the bracket, after grouping and taking out commons, the expressions in the 2 brackets did not match. So we had to again come from the beginning. We brought the 4th term in the second place and tried that. So then that worked. But that also didn't work, like directly. In the second bracket, instead of a square minus x square, we got x square minus a square. We are supposed to get a square minus x square. But we got the terms x square and a square, but in a different order, x square minus a square. But then here we have a remedy. We can handle this one. So x square minus a square, if you write it as a square minus x square, change the sign outside the bracket. If it's minus, make it plus. If it's plus, make it minus. So minus x becomes plus x and x square minus a square becomes a square minus x square. Now we see that in the 2 brackets, we have the same terms, a square minus x square. Outside we have a plus x. So gather those terms, a plus x in one bracket, a square minus x square, write it once. We have it 2 times, write it once. And then this x which is already here outside. But it didn't end here. Again, this a square minus x square is of the form a square minus b square, which is a plus b into a minus b. So a square minus x square is a plus x into a minus x. And this a plus x, which is already there. Then you can rearrange if you want. So this is how we factorize this expression, children. Yeah. All of you, please finish it now. We'll do you can try the 2nd, 3rd, and 4th as homework. We'll continue with this in the next class. Please stay in the meeting, children. Don't leave. Complete this one.
Yes, I'm done.
Yeah. Yeah, those who have finished can announce and leave the meeting. The others, all of you, please announce before you leave the call. I want you to complete this answer and then leave the call. And if you have not finished your dinner, please finish your dinner and share the pictures. All of you must share the pictures today itself without fail.
Ma'am, I have completed.
Yeah. Yeah, children.
Ma'am,
Yarni
I'm
and
not able
Completed,
to
ma'am.
Yeah, Yarni, Ashwarya, and Shreya can lead the call.
Completed, ma'am.
Ma'am, I'm not able to see the slide, ma'am. Can you start it?
Oh my God. Harsha, you were not able to see it all the while, huh? Yeah, Shivam, I
just
think
now.
you finished. You can leave the call, Shivam. Yes.
Thank you, ma'am.
Yeah, thank you, Shivam. Harsha, you need to leave and rejoin, Harsha, because I've shared my screen.
Okay, ma'am. I'll try.
Or maybe fine, since it's time, I'll send a picture for you. Please complete it. I'll send the picture. All right?
Okay, ma'am.
Yeah,
Yes, ma'am.
thank you, Harsha.
Thank you, ma'am.
Ma'am, I have completed it.
Yeah, Surya. Fine. Thank you.
Thank you.
Thank you.